This is the last video on Le Chatelier's principle. We'll be able to predict which way an equilibrium system will shift when there is a pressure stress. Again, we should know that Le Chatelier's principle is an idea where if a system at equilibrium is subjected to a stress, then the system will shift in a direction that relieves the stress. Before looking at the example, let's define what pressure is, specifically gas pressure. Gas pressure is the force exerted by gas molecules onto a surface. You should know that gas molecules are constantly moving. So for example, in the jar, there's nitrogen gas, hydrogen gas, and ammonia gas molecules always moving around randomly and colliding with the inner walls of the container. The sum of those collisions over the surface of the container is what we measure as gas pressure. Pressure can go up or down depending on a couple of things like temperature and volume. But for the purposes of this video, let's just agree that more gas molecules will cause there to be more gas pressure exerted by the system. Here we have the nitrogen, hydrogen, and ammonia gas inside of a piston, which is just a chamber that has one movable piece. On the piston, there's a pressure gauge. Right now, the chemical system is at equilibrium. However, what happens if we increase the pressure? When the piston pushes down, this creates too much pressure on the system, and the system doesn't like this. Let's look at the chemical equation. Which way can the system shift, forward or reverse, to alleviate the extra pressure? I'll give you a hint. On the reactant side, if you count all of the gas molecules, there's a total of 4 gas molecules. On the product side, if you count all of the gas molecules, there's only 2 gas molecules. Would having a container full of reactants have more pressure, or would having a container full of products have more gas pressure for this particular example? I want you to think about this. Pause the video if you need to. Okay, so since there's more gas molecules on the reactant side, having a container full of reactants will exert more gas pressure. So in order to reduce the excess pressure in this example, the system would want to shift in the forward direction to reduce that pressure back. That means some of the reactant molecules will turn into product. Look at the diagram. When the equilibrium system shifts towards the product side, there's fewer total molecules inside the piston, so the excess pressure is relieved. Now, let's set this back to equilibrium. Look at where the pressure gauge is at. What if we stress the equilibrium by decreasing the pressure by pulling out on the piston? The system will want to increase the pressure back to get it back to equilibrium. To get more pressure, it'll need to shift in the reverse direction to make more reactants. Remember, the reactant side has more gas molecules than the product side. So shifting towards the reactant side, or shifting reverse, will create more gas molecules, and in turn, increases the pressure back. Watch what happens in the diagram. Alright, so creating more of those reactant molecules will increase the pressure back. I hope you found this visual aid helpful. Here's the first example. The chemical system above is at equilibrium. Predict which direction the chemical system will shift if we decrease the pressure. So the stress here is that there's too less pressure. We just need to figure out which direction the equilibrium should shift to increase the pressure back. In other words, which side of the chemical equation has more gas molecules? Take like 5 seconds to figure out how many gas molecules are on the reactant side, and then how many gas molecules are on the product side. The reactant side has 3 gas molecules. There's 2 nitrogen dioxide gas molecules and 1 oxygen gas molecule. The product side has 4 nitrogen monoxide molecules. So to increase the pressure to get this system back to equilibrium, the system will want to shift towards the product side, so go in the forward direction. Here's the second example. The chemical system above is at equilibrium. Predict which direction the chemical system will shift if we put more pressure on the system. So the stress here is that there's too much pressure. Let's figure out which direction the equilibrium should shift to lower the pressure back. In other words, we want to figure out which side of the chemical equation has less gas molecules. Take another 5 seconds to figure out how many gas molecules are on the reactant side and how many gas molecules are on the product side. All right, so the reactant side has 3 gas molecules because there's 1 carbon dioxide gas molecule and 2 chlorine gas molecules. Please note that the first reactant is a solid, not a gas, so don't count anything that's not a gas. The product side has 1 COCl2 gas molecule. To decrease the pressure and get the system back to equilibrium, the system will want to shift towards the forward direction, towards the product side. Okay, here's one practice for you to try. After you read the question and try it on your own, then you can compare to see if you've got something similar to me. So pause the video. I'm going to show you the answer in 5 seconds. Okay, for this practice, it will want to shift in the forward direction in order to decrease the pressure back. Okay, so I don't have any additional practice for you. I'm actually going to combine all of the Le Châtelier principle stresses and those types of problems into one assignment so that you can see if you can do all of them when they're mixed up together.